you guys. I warned you that this unit would go pretty quickly since this was just our first review unit from some things that we learned in middle school algebra. So we are actually learning our last learning target today, which is learning target number 4 on compound inequalities. So just kind of a refresher as we remember compound inequalities from middle school algebra. This is where we have a couple different situations. We're going to have a situation where we have two inequalities rather than just one that are joined by either the word and or the word or. So rather than just working with one inequality like we did in some previous days this week, now we're going to be working with two inequalities, and we're going to see one of these two words, which is going to indicate a different situation for us. So let's start with our and inequalities. So we'll notice as we talk about and, if we think about kind of in general what these graphs look like. So when we get to the end of an and problem, typically we have two dots, open or closed, it doesn't matter here, but we talk about all the numbers that are in between these 2 points. So for example, we'll see this in A, B, and C, but this is the typical graph that we're used to seeing as we're working with an and problem. So this first one here, we've got the number 1 and 4. So let's put a few numbers on our number line. 0, 1, 2, 3, 4, 5. And our first one, x is greater than or equal to 1. So we know we're going to need a closed dot on 1. Let's zoom in a little bit here. Okay, here we go. Closed dot on 1. And x is less than or equal to 4, so we need a closed dot on 4. So if we think about the numbers that this covers, x can be anything bigger than or equal to 1, so we could be talking about 2, 3, 4, dot, 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 continue going. Or x could be anything less than or equal to 4. So then we're going backwards. We're saying 4, 3, 2, 1, dot, 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 but we need it to include all of these things. So then we look at our list and we talk about, well, if it has to be bigger than 1 and less than 4, it can only be values between these two dots. So again, when we talk about an and problem, we're looking for a graph that typically looks like two dots connected in the middle. So let's look at letter B. So here we've got the number -4 and -2, so let's put some numbers on the number line. We'll go -5, -4, -3, -2, -1, 0. We'll get a handful on here. That's when we have x is numbers bigger than -4, so we want an open dot on -4, and less than or equal to -2. So a closed dot on -2. So numbers smaller than -2 would be bigger negative numbers. So for example, -3, -2, or sorry, -3, -4, -5, dot, dot, dot. Numbers bigger than -4 would be getting closer to 0. But we want both of these situations covered. So we're going to connect in the middle of these 2 points. And our last one here, letter C. This time we've got -4, -3, -2, -1, 0, 1. Again, just putting a handful of these numbers on the number line. We've got a closed dot on -3 and open dot on 0. And this is an and situation. Although we don't see that word and, if we don't see the word or, we know we're working with an and situation. And we can kind of look at this and rewrite this if we wanted to. We could say x is greater than or equal to -3 and x has to be less than 0. So when our x is in the middle with no words on this situation, this also indicates an and situation. So we're connecting again in the middle of these two dots. All right, let's move into a few more complicated situations here. So again, we don't see the word or, which indicates we're working with an and problem. Now, we said a compound inequality is working with two inequalities. So when we solve this, we're going to have kind of like two equal signs. We would draw two lines in this problem. So our goal is to get x by itself. So as we do this, we need to get rid of a +2 on both sides. So -2 And instead of doing this in 2 spots, now we have to do this on all 3 sides of the problem. So negative 3 get 2 smaller is negative 5. X stays in the middle. 7 take away 2 is 5. So this inequality shows for us that we have all the numbers between negative 5 and positive 5 that will be included here. So we'll put negative 6, negative 5, 4, 3, 2, 1, 0. 1, 2, 3, 4, 5, 6, a few numbers on here. We've got 2 open dots on this problem, one on negative 5 and one on positive 5. And this is an AND situation, so we're connecting all the points between our 2 dots. It has to be greater than negative 5 and less than 5. So all these numbers in between would work for this situation. All right, our next one here. Again, it looks like an AND situation. I don't see the word OR, and we're dealing with 2 inequalities, and we want to get X by itself. So let's go ahead and subtract 1 from all of our sides here, leaving us with 4 is less than or equal to 4x is less than or equal to 12. Now x is still not by itself. We need to get rid of a times 4 by dividing by 4 in all 3 places. So we'll have 1 is less than or equal to x is less than or equal to 3. So let's put 1 on the number line. We'll go 0, 1, 2, 3, 4. Close dot on 1, close dot on 3, and we want all the numbers between these 2 dots. All right, now we're going to look at our second situation, which is a compound inequality using the word OR. So now as we look at this example, typically we've got a number line. Open or close dots don't matter here. But instead of talking about the numbers between these 2 points, we're saying we want it to be less than this number or greater than this number. So as we create our number lines in this kind of situation, our OR inequalities, we're going to see typically graphs where arrows are pointing away from each other. So let's look at a few of these examples. So our first one, we have x is smaller than negative 3, or x is bigger than or equal to 0. So let's put these numbers on. We've got, let's zoom in again. We'll go negative 4, negative 3, negative 2, negative 1, 0, 1. So close dot on both negative 3 and 0. And we'll see here for this one, we want x to be smaller than negative 3, so going towards our smaller numbers, or x to be bigger than 0. So we'll know these numbers between these 2 points, like negative 1. Negative 1 is not smaller than negative 3, and it's not bigger than 0. So this isn't going to fit as a solution here. Our solutions are just where our lines and our points are. So we'll notice, as we talked about an OR inequality, our arrows are typically pointing away, and we see that here. All right, let's do another. Now we've got 0, 1, 2, 3, 4, 5. So we've got less than, so an open dot on 2, close dot on 4. X is smaller than 2, or x is bigger than or equal to 4. So again, all the numbers smaller than 2, or all the numbers bigger than or equal to 4. Nothing in between these 2 points. And our last one here, letter C, we've got 3, 4, 5, 6, 7, 8. Close dot on 4, open dot on 7. We want numbers bigger than 7, or numbers smaller than or equal to 4. So again, we'll see in this OR situation that our arrows are pointing away from each other. All right, letter D. Now we can kind of think of this as 2 separate inequalities. So we've got one inequality, and then another inequality here. So we're going to solve these almost as separate problems. So we'll start here with this one. To get x by itself, I'm going to add 4 to both sides. leaving me with x is less than negative 7 get 4 bigger is negative 3. So that's our first situation. Our second problem, we'll subtract 3 from both sides, and we'll get x is bigger than 1. Again, with the word or in between. So we'll have negative 4, negative 3, negative 2, negative 1, 0, 1, 2. We'll have an open dot on negative 3, an open dot on 1. We want numbers smaller than negative 3 or numbers bigger than 1. And again, this is an or problem. Our arrows are pointing away from each other. All right, letter E. Again, as we look at this problem, we'll think of this as two separate problems. Our first problem and our second problem. So in our first problem here, we'll go ahead and subtract 1 from both sides, leaving us with 2x is less than 0. To get rid of times 2, we'll divide by 2, giving us x is less than 0 divided by 2 is 0. My second problem, we'll go ahead and minus 5 from both sides, leaving us with x is greater than 3. So as we look at our problem here, we have x is less than 0 or x is greater than 3, and let's plot this. Open dot on 0, open dot on 3. X is smaller than 0 or x is bigger than 3. And again, my arrows are pointing away from each other. Now let's take a look at the challenge. Again, as we get to assessments, unit tests here in this class, you'll have opportunity to answer challenge questions. So let's see what a challenge might look like for this target. So here we've got an and situation, and we see the word and in here. So we imagine when we get to our graph that we're going to have something that looks like 2 points connected in the middle. And so let's check it out. Here's our first one. And here's our second one. We'll think of these kind of as two separate problems here. Okay, so first off, we'll add 7 to both sides, leaving me with 3x is greater than or equal to 12. Now we'll divide by 3 on both sides, leaving us with x is greater than or equal to 4. My other side here, minus 6, leaves us with 2x is less than or equal to 6. Divide by 2. It is less than or equal to 3. The word and in between. Now take a second, pause this video, try and graph this situation. Welcome back. Okay, so we know we're going to have a closed dot on 3 and a closed dot on 4. So my first problem here says x needs to be greater than or equal to 4, and x is less than or equal to 3. Now remember, when we're talking about and, we're talking about the things these both share. And typically our line is in between these 2 points, and I don't see that in this situation. We can't possibly have a number that's bigger than 4 and smaller than 3 at the same time. So actually, this problem here becomes a no solution. Remember, when we're talking about and, we're talking about what can they share at the same time here. It's bigger than something and smaller than another thing at the same time. Will you pause the video and try this challenge question first, and then play it when you're ready to see a response? Okay, welcome back. So this is an or situation. So again, as we think about what we would expect in our answer, we're going to think about arrows pointing away from each other. So here we go. Let's start with our first half. Okay, so this first one here, we're going to go ahead and subtract 1 from both sides, leaving us with negative x is less than 1. Now we have a times -1 that we need to get rid of, so we're going to divide by -1. And check out here, this is a red flag. Divide by -1, divide by -1. So I need to flip the sign. A positive divided by a -1 gives us -1. The word or in between. This side, +3 plus 3. 2x is greater than 8. To get rid of times 2, we'll divide by 2 on both sides, and we'll get x is bigger than 4. So here is our solution. And as we graph this, we're going to put -1, 0, 1, 2, 3, 4, 5, open dots on both. Now notice what's going to happen here. X is bigger than 4 goes this way. X is bigger than -1 also goes this way. So if we're thinking about it, it has to be either or one of these situations. We'll see this is already covered here when talking about numbers that are bigger than -1. So rather than saying x is bigger than -1 or x is bigger than 4, we'll see here that x is bigger than -1 actually covers all of these values. So we're going to adjust our answer here to just be x is bigger than -1 because that covers everything here. Now you may wonder about this open dot, but you'll notice as x is bigger than -1 comes this way, it really fills this solution in. So x is bigger than -1 is what we would revise this final answer to be. Now keeping in mind these last two are challenge problems, so this would never be the level of problem you'd be required to solve on a unit test, but it's always good to challenge ourselves as we look at some of these problems. Great work, guys.